Hello wonderful person, this is Anton, and today we're going to be discussing some somewhat unusual discoveries about brown dwarfs. The objects we often refer to as the failed stars, because for a very long time the scientific community viewed brown dwarfs as objects that just did not get enough mass to become stars, and instead remained as something in between stars and planets. Basically a kind of a hybrid. But for a very long time, scientists have also assumed that many of these objects are probably alone, with only some of them coming as binaries. But a lot of recent observations seem to suggest that in most cases they come as binaries, and even more so, many of these binaries seem to be kind of strange. And well, in this video we're going to be discussing one of the strangest binaries discovered so far, where two objects orbit so close that they're basically doing this. And turns out that because of this phenomenon, there's a very high chance that sometimes in the future, one of these brown dwarfs is actually going to transform into something entirely different. And so in this video, we're going to focus on this recent study that as always you can find in the description below, as well as a few other discoveries about brown dwarfs and about their somewhat unusual properties. But first, let's briefly establish, so what is a brown dwarf? And how is it not a star? Well, when it comes to a kind of a hierarchical structure in the universe, they're literally the middle ground between a giant gas planet like Jupiter and an extremely small star like a typical red dwarf. And normally their mass is between 13 and 80 masses of Jupiter, but some of them can be a little bit smaller and some of them can be a little bit bigger. And the reason they're not stars is because they just don't have enough mass to trigger the process of hydrogen fusion. But some of them do have other types of fusion, which is why quite a few of them do get pretty hot. And so at least some of these brown dwarfs can actually start fusing deuterium, or the heavy isotope of hydrogen, that allows them to produce just a little bit of heat. With some other brown dwarfs even being able to fuse things like lithium, which eventually makes some of them pretty hot. But in order to ignite lithium, the object has to be at least 65 Jupiter masses, and so only supermassive brown dwarfs that we've discussed previously can actually achieve this. Which means that for most of their lifetime, brown dwarfs generally remain the same and only radiate heat extremely slowly over time, which means that it will take them billions and billions of years to finally fade and cool down. But a series of recent discoveries, including this record-breaking binary system, basically suggests that a lot of these objects seem to be way more active than we actually thought, and may even transition into something else in a way we never imagined. And while the strangest object discovered so far is of course this, ZTF J1239 plus 8347, the object that's now changing our perspective on binary systems and on brown dwarfs. Now this is located approximately 1,000 light years away from us in the constellation of Ursa Major, and surprisingly it was discovered by using the Zwicky Transient Facility, the automated facility that basically looks for deviations in brightness, and that's usually responsible for discovering things like nova and supernova, basically stars changing brightness in a relatively short period of time. And that's actually what makes this system so strange. It did not go nova or supernova, but it did trigger the facility, because here it changes in brightness every 57 minutes. And that's because in this case astronomers confirmed that these two brown dwarfs orbit each other at incredible speeds. This is a truly unusual orbital period, and in terms of the size of the system here, this basically fits into the same volume as the distance between Earth and the Moon. In a sense, these objects are almost touching. And that's of course what makes this so exciting, because turns out that one of these objects is just a little bit more massive, and as a result is stealing some of the material from its partner. And so here there is definite evidence of a mass transfer. And as this larger object is siphoning more and more mass, it's obviously growing larger and larger in size. But in this case, as the material hits the surface and accretes on the surface, it creates a kind of a very bright blue hotspot that then glows in the ultraviolet. This is usually known as the direct impact accretor. But normally we see these in binary systems involving white dwarfs or neutron stars, where the mass transfer is so dramatic that it hits the much more massive star at very high velocities. And normally these objects experience rapid mass transfer, very high accretion rates, and produce a lot of X-rays. But this is the first ever time we've seen this around brown dwarfs. Brown dwarfs that are closer to planets in terms of properties than to stars. And so finding this in brown dwarfs suggests that these failed stars can experience the same violent dynamic physics as real stars. But for these two objects, this is also important for another reason. This has a profound implication for star evolution. Normally, brown dwarfs are basically seen as a kind of a dead end, as in they don't really transform into something else, and they just slowly get colder and colder, eventually becoming almost invisible. But in a very tight binary system like this one, the brown dwarf gaining mass has a very high chance to eventually become heavy enough to finally ignite hydrogen and to finally become a real star. And this can happen in one of two ways, either by basically sucking all of the mass from the partner until the partner becomes a planet, in which case we get a tiny star and a massive planet orbiting around it on a very tight orbit, or these two objects could eventually merge and suddenly acquire enough mass to become a single star, but in this case very likely without any partners. And so in either scenario, the failed star is now going to transform to an actual star. It's almost like some kind of a cosmic second chance at life. With this example showing us that binary interaction can actually lead to some major evolutionary stages that we never knew existed and that nobody expected we would physically find. And also stages that single brown dwarfs or single stars can never acquire, which obviously makes this a pretty exciting discovery. But based on some of the recent discoveries, this may actually be a lot more common than we initially assumed. And mostly because a lot of additional studies started to discover that many different brown dwarfs we expected to be alone turn out to be binary. And so this idea of binary brown dwarfs in a very tight orbit is actually slowly becoming a much more common discovery. For example, for nearly 30 years, we've known about the object known as Gliese 229b. This was considered to be a kind of a poster child for brown dwarfs, and it was actually the first one to officially be confirmed back in 1995. You can see the original image from the Hubble right here. But it always puzzled astronomers because here it was a little bit too dim to physically measure its mass. But in one of the recent studies, scientists officially confirmed that this is also not a single object, but instead contains two brown dwarfs orbiting every 12 days. So not as close as the previous discovery, but still close enough to influence each other and possibly one day get much closer. With this discovery essentially suggesting that many objects similar to this, that we thought were just single brown dwarfs, might actually be tight-knit binaries that are just very difficult to tell apart. And this of course changes our understanding of how exactly these objects seem to form, with several studies now suggesting that many of these brown dwarfs possibly form as a result of fragmentation from some kind of a single object in the gas disk around a star, because quite a few of these binaries have now been confirmed. But the complexity of these systems does not stop at pairs, and so here we have this quadruple system referred to as J1040-3551 that seems to contain two red dwarfs that are almost brown dwarfs. Basically they got lucky enough to have enough mass to become stars, that are then orbiting two brown dwarfs that did not get enough mass and will remain as brown dwarfs unless they somehow collide with each other. Which basically makes this a very unusual system that will probably be used to try to understand how these binaries form and how some of them might eventually transform, with additional objects like J1446b showing us a combination of both, a red dwarf orbiting a brown dwarf, or basically showing us that these binaries do come in a lot of different flavors. But in general, what we're seeing now is essentially a kind of a paradigm shift in viewing these failed stars, and mostly because we can now confirm that some of these binaries are eventually going to transform and will become stars sometimes in the future. Now for this particular pair, it's not entirely certain when, but because both of these objects are at least 60 to 80 masses of Jupiter, and they essentially require over 80 masses of Jupiter to become stars, right now scientists don't think it's going to take too long. Here, because of the shrinking orbit, and because of the rate of siphoning of the mass, this transition might eventually take place in approximately 1 million years. So not billions of years like we usually discuss in astronomy, but just over 1 million years. And that means that in the near future, in terms of astronomical terms, our galaxy might acquire a new star, a new red dwarf that might even contain a very unusual planet. And so here we have a confirmation that many brown dwarfs are definitely not alone and are definitely not as dead and not as static as we thought. But with new observations from Vera Rubin Observatory, researchers actually expect to find dozens more of these systems, which will possibly help us understand what happens when these evolutions occur and how these systems eventually end. And so at least for now this is just the beginning of these observations, mostly because this is the first such object we've ever found, the first brown dwarf that gets that second chance. On that note, we'll definitely come back and discuss this more once there are some additional discoveries. Until then, check out previous videos on brown dwarfs in the description below. Thank you for watching, subscribe, come back tomorrow to learn something else. Support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.